Hey everyone, it's Treasure again, your instructor for the 3D animation course in Blender. In this video in particular, we're going to be going through the theoretical overview of animation. What exactly is animation and what are some concepts in the animation space to help you start animating. So let's get started. Hello everyone, welcome to chapter 2 of our 3D animation crash course with Blender. In the last chapter, we introduced you to the software and you created your first render in Blender. In this chapter, we're going to be throwing you straight into the meat and you're going to create your first animation in Blender. But before that, there are some key concepts in the world of animation that you need to understand before you can start animating in any software in general. So first of all, what is animation? Animation in its simplest of definition is simply the art of making image elements move autonomously. Now, I say autonomous because if I move this image of a square around the screen, we will not perceive that as animation because as you can see, I clearly am moving it. For it to be perceived as animation, this movement needs to feel autonomous. The square needs to feel like it's moving on its own. However, the movement in animation is an illusion. What we're actually seeing is a series of still images or still pictures being displayed at very high speed to make it look like it's moving, specifically at the speed of 24 pictures per second. Each of these pictures are called frames. A frame is the unit of animation because it is a single image in a series of pictures to be displayed sequentially. But thousands of images of the same picture with nothing changing will not be perceived as animation because for movement to occur, there needs to be some sort of change. Hence, to create the illusion of motion, each of these frames needs to show the object in a different state or position. But be careful though, because having an object move from point A in the first picture to point B in the second picture will not register in our brain as a smooth motion. For movement to be perceived as smooth, the transition of an object from point A to point B has to be gradual. So, if animation is the art of making images move, the illusion of movement is created by gradually changing an object's state over time. However, time works a little bit different in animation because in animation, time is measured in frames. It takes 24 frames to make 1 second of smooth animation. The less frames per second, the more choppy the animation will look. The more frames per second, the smoother the animation will look. But if time in animation is measured through frames per second, how do we record change in animation? Enter keyframes. Keyframes are types of frames that record the major points of change or key points of change in an object's state, properties, or action. Now, there are two main types of keyframes. The start keyframe that records when the object's action begins, and the end keyframe that records when the object's action finishes. If the start keyframe is where the object is before the change, the end keyframe is where the object will be after the change has occurred. But between the start keyframe and the end keyframe is a couple of transitional frames known as in-between frames. In traditional 2D animation, artists usually have to manually draw each transitional frame between the main keyframe one by one. But in 3D animation, all we need is the start keyframe and the end keyframe, then the computer generates the in-betweens for us in a process known as interpolation. So interpolation is the process where the computer looks at our start keyframe and our end keyframe and then mathematically generates the in-between frames for us. So if we go back to our theory of motion, we can say that time is measured by frames, change is recorded by keyframes, and the graduality of change is handled through interpolation. So in our next video, we will be putting these concepts into practice in Blender. So see you there. And that's it for animation overview. In our next lesson, we're going to put this into practice in our 3D software of choice, which is Blender. So be sure to check that out. Again, like and subscribe, share, and if you have any questions about this chapter, be sure to leave them in the comments, and I'll be sure to answer them. Thank you.
Enjoy all these premium courses in this channel for free.